In these clips, we see Ju-87 Stuka dive bombers flying in formation and attacking targets. The U.S. Army Air Forces was so impressed with the performance and bombing accuracy of this type of aircraft that it desired to include a dive bomber as part of its air arm fleet. The intent of this video is to review the U.S. Army Air Force's A-25 Shrike dive bombing program and why the program was canceled mid-war. The A-25 is a modified Navy carrier-based SB2C Curtiss Helldiver. This image shows a typical dive bombing attack. The target is here. The dive bomber starts a steep 70-degree dive, keeping his eyes on the target. The dive brakes and/or flaps are deployed to arrest the plane's natural tendency to overspeed and improve handling. The dive brakes on a Curtiss Helldiver. The plane releases the bomb here at around a 1,500-foot altitude, then recovers from the dive and exits the area. The dive brakes on a German Ju-87 Stuka dive bomber here. The Curtiss SB2C Helldiver dive brake stowed and location with folded wings. The dive brake slots reduce buffeting. Dive brakes and flaps extended on an A-36 Apache or Invader. The A-36 is a speed brake and bomb rack modified P-51 Mustang. The advantages of dive bombing over low-altitude glide bombing include a steeper 70 to 90-degree dive angle, improving accuracy. Bomb release is closer to the target, increasing accuracy. Higher bomb penetrating power. The plane's dive speed is added to the bomb's gravity acceleration to target from release. Shock value of a surprise quick attack. Disadvantages of dive bombing include dive bombing requires more skill, higher attack G-forces, which may affect pilot performance. Aircraft needs to have special features for dive bombing, like dive brakes and bomb sight, increased vulnerability to ground fire. Instead of designing a new dive bomber model, the Air Force evaluated 3 Navy models for consideration. The A-35 WWII Vengeance. The A-35 is a modified A-31 as shown, where the A-35 incorporated a modified wing. The Douglas SBD Dauntless, which became the A-24 Banshee dive bomber, and the A-25, which was built on the Curtiss SB2C Helldiver. This 1942 Curtiss magazine ad for the A-25 dive bomber indicates the dive bomber's speed and destructive power will have an influence on the war's victory. The plane's dive brakes are extended here. This June 1943 image shows a cutaway of the Army Curtiss A-25 dive bomber from an Air Force Historical Material Command document titled A Case History of the A-25 Airplane Project. The final version did include a tail gunner operating a single 50 caliber machine gun. Design work on the Army Helldiver derivative started in April 1941, as defined in this Army Air Corps contract document. Since the A-25 bases would be on land, the following 7 modifications would be needed to convert the carrier design Helldiver to the ground-based Shrike dive bomber. This included elimination of the wing fold mechanism, omit the carrier arresting hook, increase wheel and tire size, change tail wheel and type, remove catapult fittings, remove fire extinguisher, replace Navy radio with Army radio. This video shows the Navy Helldiver with its folding wing mechanism articulating from deployed to stowed. Surprisingly, removal of the folding wing features only saves 95 pounds, as shown in this April 1941 SB2C to A-25 plane modification and weight reduction document. The Army version of the Curtiss Helldiver will be designated A-25 attack bomber, as seen in this August 1944 specification and performance document. 900 units were delivered by March 1944. Normal armament included 2 wing-mounted and a single flexible mount 50 caliber machine gun. Bomb load is either a single or 2 500-pound bombs, a single 1,000-pound bomb, or a 1,600-pound bomb, or a 2,000-pound torpedo. The plane incorporated self-sealing fuel tanks. The pilot and gunner were protected by armor, and the pilot's windscreen was ballistic glass. Air Force dive bomber suitability findings and recommendations are discussed in this March 1943 document titled Proceedings of Board of Officers for the Purpose of Evaluating Current Dive Bombers Now in Production. The 12 evaluation officers are listed here. The Navy derivative planes under consideration are the A-35 Vengeance, A-24 Banshee, and A-25 Shrike. The evaluation considered forward-facing gun firepower, dive bomb accuracy, maintenance, and speed at low altitude. The planes were evaluated based on expected dive bombing performance in active theaters. This included the plane's vulnerability and ability to defend itself from enemy fighter attack, evasive action ability, Bombing accuracy is compared to the existing USAAF fighter bomber models A-36 Apache, P-51 Mustang, and P-39 Airacobra, all equipped with the N-3A modified gun sight. Bombing accuracy is compared to the existing USAAF light bomber models A-26 Invader and A-20 Havoc, both equipped with the N-3A gun sight. This image shows the A-26 and A-20 light bombers. This image from a 1945 fighter gunnery manual shows the N-3A gun sight. Usage differences between Air Force dive bombing land targets and Navy dive bombing ships. The dive bomber ranking order is listed as Shrike, Vengeance, and Banshee. However, none of these dive bombers are suitable for Air Force usage. They are all extremely vulnerable to fighter attack and would require fighter escort. They are too slow at low altitude for effective enemy fighter evasion. The accuracy of the derivative Navy dive bombers in consideration do not match the bombing accuracy levels of existing Air Force models. The Air Force models can better protect themselves from enemy fighters by their speed and their fighter characteristics as design. If the Navy derivative models gain better bombing accuracy by usage of the N-3A gun sight, the lack of combat speed is still an issue. The Air Force models can carry larger strike loads. The Mustang can carry two 1,000-pound bombs, as can the P-47 and P-38, as defined in this 1945 AAF tactical planning document, which is around twice the Helldiver's bomb load. Light bombers will strike ground targets more accurately like tanks and airfields and dive bombers. The Navy's need and usage for a dedicated dive bomber does not imply the Air Force also has a need for a dive bomber. In naval battles, clashes are over in a matter of minutes. Dive bombers deployed from aircraft carriers can fend for themselves during an attack. Dive bomber losses may be large, but the payoff of a sunken ship is worth the large losses. Battles are over quickly and are usually decisive. The Army Air Forces, on the other hand, operates daily. Large daily sortie losses are unsustainable, and large dive bomber losses won't be worth the target destruction payoff. Fighter bomber losses per sortie will be much less than dive bomber losses per sortie. The board recommends all Navy derivative dive bombing aircraft procurement is to stop immediately. The manufacturing facility should switch over to either light bomber or fighter bomber production. If needed, the A-36, P-51, and P-39 will fulfill any dive bombing requirements of the Army Air Forces. These recommendations were approved on March 22, 1943. This page outlines the state of dive bombers in 1944 from a December 2010 Air Force magazine article titled The Last Dive Bombers. The Ju-87 Stuka was deployed throughout the end of the war. By 1944, all World War II belligerents realized that single-seat fighters could fulfill the dive bombing role. The RAF Typhoons, USAAF P-47s, and German FW-190s fulfilled the dive bomber roles. This page lists 5 serious errors with lasting consequences the German Air Force made during World War II from a 1988 Air Force History Special Studies document titled Air Warfare and Air Base Defense, 1914 to 1973. The list includes inadequate training of reserve pilots, overestimated the value of dive bombing, lacked sufficient numbers of transport aircraft, failed to deploy a heavy long-range bomber, inadequate production of aircraft during the early war years. Around 900 A-25s were built, however, they never saw combat with the Army Air Forces. By November 1943, the planes were scattered about 15 airfields performing various functions. This included cargo carrying, towing aerial targets, night search training, glider towing, transition, and cross-country flights. Most of the planes had issues. This table lists the deficiencies the planes experienced. This document lists the disposition of the 900 A-25s as of April 1944, some 11 months after the program scrub. These aircraft are entirely unsuitable for combat. These planes are also not suitable for target towing or pilot training. Australia has canceled 140 out of the 150 ordered. 60 have been modified as cargo carriers. 410 were transferred to the Navy in March 1944. This leaves 465 A-25s without any purpose. These can be assigned or classify them as obsolete for any military application. If you've enjoyed this Army Air Force A-25 dive bomber program review and found this obscure topic informative, please consider liking, commenting, and/or subscribing to World War II U.S. Bombers.